Greetings, everybody. This is Delta Core, and it's a good day today. Well, better than most. This is going to be a follow-up from the 3D game. Well, actually, it's not really a follow-up. The 3D game was more or less me following a course. This is going to be a practice project in order to get my 2D platformer skills going. Try to understand and as well as transfer what I've learned from my 3D course to my 2D construction of my own making. As you can see, we have a base sprite here. This is, of course, Kimiana, the primary character. Right now, we're just going to be using her sprite as a placeholder because her sprite will be the basis for all other character sprites. I'll show you around. I'll give you a quick show around as to the basics. What I took from the original construction and what I added to my own. So I haven't really done anything with the enemies, but this is what's going to be called the base movement script. As you can. Oh, sorry. It's taking. Okay, I'm gonna get rid. I've tried. I'll leave that for later because I'm not working on that. I won't be working on that right now. But the base movement script is what's controlling my player character here, and she's made up of a box collider and a two box colliders and a circle collider. I will not be talking about what the bottom box collider is going to be for, but simply, well, okay, I'll explain. It's for jumping, but that's for a later date. I haven't figured out how I haven't figured out jumping because in the 3D project I had problems with the jumping controls, and it's something I want to tweak for my own for the purposes of the game. Anyway, this was done mostly with a lot of help from the Brackeys server. I've referenced them many times, as well as a Bracky YouTuber. You can follow his content. Regardless, back to the topic. The it is also based on slightly on a tutorial I followed from Brackeys about how to make your first 2D game. But I wanted to do this on my own, kind of see how far I could get on my lonesome. This whole thing is drawn in Photoshop. It's transferred over here, and they all have their have their own colliders. The basic premise here is that the base is that just like what the Zenva Academy taught me, you create an empty game object and then you put the model inside. This would I'm not too sure why that is, but I'm pretty sure there's a reasonable explanation for all of it. But that's neither here nor there. So this is here in the event that I do manage to get around to animating, but right now we're just trying to get the mechanics up and running. As you can see here, the input.key down, it's all of this float x equals input get axis horizontal speed times speed. This is the exact same movements script as the player in the Zenva course. Right here. No, wait, right here. Except I can omit the z-axis because this game doesn't really have a z-axis. There's a 2D game, it doesn't have a z-axis. Now, one of the concerns I was having was whether I should be using Vector 3 because, once again, we're essentially accounting for a non-existent axis which could potentially cause problems, but it hasn't caused problems yet. And on top of that, it would require me to learn like Vector 2s. On top of that, Vector 3s for some reason seem to work fine. As long as I just make sure to like block out all the z-axes or try to keep everything. Actually, No, z-axis. No, that's. I'm gonna try not to be too rambly here. So it's essentially a lot of it is the same thing, except the code runs a 2D in the background. Something that I kind of was something that I was unsure about was this. This is called a platform, and if you recall in games like Mega Man, there were platforms that you could jump through. So let me demonstrate. You can jump through. You can walk through. You can walk through them. You can jump through but you can also land on top of them, and this is with the aid of the platform effector. The platform effector simply takes in an edge collider, which you have to activate used by effector here. There's a collider mask, which will tell you which objects you want it to be affected by. One-way grouping. So the purpose of one-way grouping is that it groups all of an object's colliders into a single group. Now, now my concern was that I would essentially have to do all of this by scripting. I'm just kind of thankful that Unity has a very simple kind of thing already made out for that. It just comes to show that platforms that you can jump through are such a common like gaming convention in 2D platformers that it should be just normal. So, you notice the camera here. That is actually the one thing that I am extra proud of. This was a pain. So, I actually had a lot of ideas for what to do with the camera in my original design document. Originally that the camera was supposed to follow the mouse, and the character was essentially supposed to act as a border for the mouse. Was supposed to act as a border for the mouse. So essentially, if your mouse like went too far off, if your mouse went a certain level, went a certain distance, it would actually catch onto the character model, and then it would lock the screen there, but allow your mouse to do this. This is a much more streamlined and simpler mechanic. Simply have the camera follow an area between the mouse and the player. This will allow you to keep track of where your player is, as well as keep track as to where your oh dear this will allow you to keep track of the location of the player, as well as keep track of your point of aim, because remember, this is supposed to be a 2D side-scrolling shooter. It would be very important. Now you're probably wondering why there are two platforms. I'll explain that at a later date, but simply put, this game is supposed to have lanes, so you have to represent a z-axis. So the game, because it's a 2D game, it doesn't really have a z-axis, but this will exist. But the lane system exists to replicate a z-axis. So this white platform would actually be further back in the background. I know that may not make sense, but it's all of this is just kind of placeholders, or just they're just there so that I can know where to draw over. I assure you, it will all make a lot more sense once the art assets are drawn in. But oh my, this camera was a pain and a half. But I managed to get a way around it. So the basic idea is that you need to get both the mouse position and target position and find the area in between. To explain, so you can't just get input mouse position like normal here, because how mouse position is calculated is very different from how the location of object is calculated. If you just put input mouse dot position, it's going to go all over the place because it's read very differently. What you need to do is that you need to focus it to something relative to the screen to world point. Next, you have target position. So you want to. So the first thing to do is that we need to set these two. We need to set these two objects, mouse and target. Now, obviously, what you do is that you get onto your camera and you essentially you make an you make sure that the camera is reading information from your player From there, you once you get your character, so that's the easy part. The easy part is get your character position. The major problem is getting your mouse position. So next we created a new vector tree called aim position, which I know this sounds very this because the thing is aim position is supposed to get its information from this calculation here. Target mouse equals target position minus mouse, because we've set mouse here to equal main camera dot screen to roll position. That means it reads where your mouse is relative to the camera screen. From there, you float dot equals float mouse dot magnitude. Now this is admittedly a script that I actually don't know, but this is supposed to get the distance from the target to the mouse. And target hit mouse dot normalize. This will normalize the target mouse as a new vector. So next we create the offset. The offset is going to be target mouse, which is a vector, which is going to call the vector tree here, and then it's going to grab the information from the distance plus 0.5 f. Unfortunately, I'm gonna have to talk to Brackeys to kind of get a better understanding of this script. Part of it's oftentimes not in. It's never enough to just like have something work. You need to understand why it works. Otherwise, you're essentially only going to be able to make your one thing. So I'm still learning here. It's gonna be very difficult, but you gotta keep trying. You gotta keep at it. The real point of the real thing that I was stuck on was I actually had no idea. I was stuck at aim at this area. This was the script that I was actually stuck at, because it was actually instead of aim position. This was replace aim position with transform.position. The idea was that transform.position is going to be the vector tree, which is going to be offset x plus which is this is accounting for what the x, y, and z. If you want to get into the specifics, instead of just calling the object, you want to put it in brackets, because when it comes to vector trees, it's all divided into x, y, and z axes. So it goes x, y, z, and so it's offset x. So that's the x object of the x, not the number of the x axis that belongs to the offset value. I don't know how better to explain this, but you're just gonna have to work. But yeah, that's the best way I can explain it, unfortunately. So you're probably wondering why these minuses are. So target mouse. So if you recall here, offset is a combination of target mouse distance multiplied by half f. Oh, I see. So the thing is, yeah, this is to get the direction from the target to from the character to the mouse position. The distance is at, well, this is to get the distance of target dot magnitude. So float distance. Okay. So you want to put dot magnitude to get the information, the distance between. All right. And target mouse, I'm not too sure about what normalize means, so I'm gonna have to. That's definitely something I'm gonna. But the reason why it's 0.5f is because it's a float. What a float is. It's a number that can go into a decimal point. And the reason for that is that 0.5 is a half. So you want to get the distance between the target to the mouse, to the player character to the mouse, divided by 2. And no, well, you can't really divide it by 2. What you can do is multiply, but you want to get a division, you want to get half, you have to multiply it by 0.5 to get your half. That's basic mathematics. Or that's basic arithmetic. Same deal anyway. So that way it's going to be the target, so it's the direction multiplied by the distance multiplied by half the distance. So that's how you get the location. Okay? So because it's already calling vector 3. Okay. So remember, so this is offset. So this thing is now calling the information, these offset values. It's calling this down here. So what I decided to do is that I figured that this was not the end point for what it should be. So essentially, I made this into a new vector 3, call it aim position, and then I'm going to call it, and then aim position is going. So instead of, I took the transform dot position, replaced it with the aim position. So I made this its own set value. Then what I did was I went back to basics. I took the original thing because I realized the camera was not following the player. This whole thing was because the camera needs to follow the player. Otherwise, the camera is just going to sit still, because what's happening in the script, what target position is screen to world, what this script does is that it actually reads where your mouse is within the screen of the camera, and the camera is fixed. You see, the camera is would typically be fixed in this one position. So if I didn't have, so as it was, like if this was just transform dot position, if I replace this with transform dot position, it would just mean that the camera would the camera would be fixed in this position, but it would be allowed a limited amount of movement based on where my character is. So that was not what I wanted. So what I did was, what if I added an extra line, and I just copied the camera follow. So I made it so that instead of the camera being essentially being fixed in that one position, it's now following the character as well as taking in the mouse position. That is how it works. I wish I was better at explaining this, but honestly, I'm just so excited because I've been working on this for 3 fucking days. I'm sorry for the swear. Like, oh dear, YouTube's gonna demonetize me. Oh, shock horror. Oh, fuck it. YouTube's a garbage fire anyway. Anyway, part of it is the coffee. Part of it is I'm so glad. I can't believe I actually got this to work. Oh god. Oh god. This is just the best feeling. This is just the best feeling, fellas. But yeah, now it works exactly as I wanted it to. It is following the play. It is following the player. It is doing, and on top of that, you can aim. You can aim to the left. You can aim to the right. So, where to go from here? Where to go from here? Well, the problem is this. So the major slip up here was getting mouse position and understanding how it interacts with the camera. Now we need to get mouse position, and we're going to make it once again. We're going to make it relative to the character, because next thing we need to do is we need to make this character sprite turn around when the mouse is behind her, because remember, the mouse represents the character's point of aim. I have another object here. It's called cursor, and cursor is essentially going to be your target cursor. It's going to be bound to the mouse position, which should be easy as piss. It should just be, I could just like do do the exact same thing I'm using for this. Get the target transform here. Instead of making it a player, make it a cursor, and just make it just land directly on the cursor, and that should be gold. Another thing that needs to be done. Another thing that would need to be done is actually getting a solid idea as to where how to get the jump fixed. So what I'm planning to do, and as well as to create an opening for a double jump system. So so this is going to be based off the original player script. As you realize, I've created this thing called the jump token system. Essentially, what I'm planning to do next is, you see this square at the bottom. Every time this square comes into contact with the floor collider, or at least something that will be recognized as the floor. Which, oh dear, I actually, oh dear, now I just realized. What if? Ah, fuck. Okay. Obviously, this is still a work in progress. I will tweak it. I will try to tweak it best I can. No, but I'll keep at it. So but the basic idea is that this bottom square box collider here, box collider 2D, is a trigger. Every time anything that is identified as a floor comes into contact with this box collider, you will get a set amount of jump tokens, as well as a max, which will go up to a maximum amount of jump tokens. The code that I'm going to be using is going to be, instead of wait, is it the landed one? Is grounded. Instead of is grounded, it's going to be instead of is grounded equals true, it's going to be if jump token is more if jump token is more than 0. So as long as you have jump tokens, you can jump. That's the basic premise. As long as you have jump tokens, you can jump. So every time you land on the ground, you get jump tokens. You'll get a set amount of jump tokens. Every time you jump, you will use up a jump token. So once you run out of jump tokens, you can't jump anymore. And that part of the script, because this is an and, which means you need to press. It needs to read a space. It needs a space bar input, and it needs to check for a secondary function. For this script, it's checking if the character model is grounded. For this coming script, it's going to check if the character model has jump tokens. So that's about where we are right now. Still trying to figure out how it all works. I'll tell you. I'll have another progress report up and running when I can get some more headway into it. I'm glad you guys could join me, and have a nice day, all of you.